So myself, Dr. R. Saravankumar, Assistant Professor, Department of EEE, Madanapalli Institute of Technology and Science. So my topic is artificial intelligence based state estimation in power system with the Phasor measurement unit. So normally state estimation is nothing but to determine the voltage magnitude and phasor angle in the power system. This is called state estimation. So in the state estimation, it contains a lot of error when you are calculating the voltage magnitude and phasor angle. But in normally in the voltage magnitude, it varies from 0 to 1.1. So there is no problem in the determining the voltage magnitude. But in power system, the phasor angle is very important. So in the phasor angle, it is varying based on the angle, and it has lot of variation. So this variation will give more impact on the power system. So we need to estimate the very good phasor angle. So we will go for, already we have conventional methods. The conventional method, we have some difficulty in the conventional method. So now we are going to calculate the AI techniques to use the phasor angle. So on other category also, we are implementing the phasor measurement unit to get very good accuracy in the state estimation. So this is our outline of our presentation. In the presentation, we have introduction. So we have conventional method and artificial intelligence method. Some how to do the data pre-processing before going to use the data, and the process flow diagram, how the training data and testing data and validation data we taken, and based on the data, how we are obtain the solution. Based on the evaluation matrices, we obtain the solution. So finally, we have the conclusion. So in the introduction part, so normally in the power system are continuously monitored in order to maintain the operating condition in normal and the secure state. So the process consists of redundant measurement in order to provide the optimal state of the current operating state. So the state estimation is a function. It is used to filter the incorrect measurement, and if there is any redundant data if is there in the power system, by using state estimation, we can rectify them. So already we have some conventional method. The conventional method, we have Gauss-Seidel method, Newton-Raphson method, and Fast-Jacob method. We have the conventional method to calculate the state estimation. So among the all the conventional method, the Newton-Raphson method has more accuracy, reliability, and minimum number of iteration, and also it has high computation speed. When compared to Newton-Raphson, Gauss-Seidel and Fast-Jacob method, it is has some drawback. The drawback is nothing but it has slow in convergence. So here we have the weighted least square estimation. So in the weighted least square estimation is one of the oldest method or conventional method to determine the state estimation in power system. So in the weighted least square estimation, based on the weight, we can calculate the state parameters, the voltage magnitude, and the phasor angle. So when we are minimizing the sum of squares to estimate the actual state, it is used for weighted least square estimation. But this estimation, weighted least square estimation, is not suitable for very larger kind of data set. So and then we have regularized least square estimation. So some drawback is there in the weighted least square estimation. The estimation of weight is very difficult in the weighted least square estimation. Now we can rectify the weight in the weight least estimation. We introduced regularized least square estimation. So in that, if the number of variable exceed the number of observation, then the measurement matrix will become complex, and we are obtaining the solution also challenging in the regularized least square estimation. So it is also one of the traditional technique. So now for that, we are going for artificial intelligence technique. In that, we are using the machine learning and deep learning technique to estimate the state parameters. So normally in machine learning, we used decision tree, support vector machine, ensemble learning, ensemble learning, ensemble boost, and ensemble back, and neural network we are using to determine the state parameters of the power system. And we also met some issue with the artificial intelligence technique such as machine learning. The machine learning estimate accurately the voltage magnitude value, but it is difficult to calculate the phasor angle. So we will go for the deep learning technique or specifically to calculate the phasor angle in the state estimation. Now in that we are using the gate recurrent unit and long short term memory, and bidirectional LSTM. We are using the three different model to calculate the state parameters in the power system. Then we are comparing the machine learning and deep learning. So in the among the machine learning, we have artificial neural network will give the best results compared to uh, other machine learning techniques such as decision tree, support automation, and ensemble boosting and backing. In similarly, deep learning also among the three category GRU and LSTM, VLSTM model, GRU provides the better results. But in case of in comparing the machine learning and deep learning provides the maximum output and better accuracy to calculate the state parameters in the power system. So but in machine learning, the voltage magnitude is accurately getting by using neural network, but neural network has some trouble to calculate exactly phasor angle in the state estimation. So we will go move on to deep learning technique. In the deep learning technique, GRU ultimately calculating state parameters of power system such as voltage magnitude and phasor angle by using gate recurrent unit. So from that we concluded that so this artificial intelligence technique, among the artificial intelligence technique, deep learning is give better result to calculate the state estimation in the power system. So now we go to how we are data is pre-processing. So the data we pre-processing, the data set totally consists of voltage magnitude and phasor angle, and we have the real power and we have the reactive power. So in that voltage magnitude and phasor angle is the input and real power reactive power is the output. So we are using totally 567 data set to calculate the state parameters in the power system. So this data set we derived based on the holomorphic embedded based continuation method. So based on this method, we calculated, we derived the data set. So this data set consists of n number of data set, totally 567 data set for different loading we are obtained. So up to 200% loading we obtain the data. Totally we got 567 data we used for machine learning and deep learning technique. So in the process flow diagram, so in the process flow diagram, we have the initial data set. The data set will be the 567 data set. So the data sets splitted into two category. One is training data and validation data, and we have the testing data. Then the data splitted, then we got to select the suitable model to perform the parameters. So finally, we got the one appropriate model to calculate the state parameters in the power system. So then finally we obtain the model, we can save the model. Once the model is obtained, then based on the evaluation matrices, then we can come to conclusion which model is performing more better to calculate the state parameters in the power system. So from that conclusion, we came to the conclusion. So the power system parameters are estimated by using voltage, weighted least square estimation, and regular least square estimation, machine learning technique, and deep learning technique. So among that, so it perform AI techniques perform better in to calculate the state estimation power system. Among the AI technique, GRE will give better results both calculating the voltage magnitude and the phasor angle. So in the comparatively study we taken, so the measurement of error in state estimation will be reduced by using the artificial intelligence technique. So so we are from the conclusion. So all the technique we have the weighted least square, regular least square, and Newton Raphson method, and machine learning we have AN method, and deep learning we have GRE method. Compared to all the 5 to 6 method, so gate recurrent unit the suitable for to calculate the state estimation in the power system. So so the proposed model we effectively tested in the IEEE 14 bus system and 30 bus system. So whatever the power system to calculate state estimation, we have to implement with the standard IEEE test system. The standard IEEE system we taken for IEEE 14 and IEEE 30 bus system. So it is IEEE 14 this system we have 14 buses, and 30 bus system we have the 30 buses. So we can place the we collect the data set, then we can performing, we tested, and finally we obtain the model GRE model is suitable for calculating the state estimation in power system, right? So next, in addition, we added the phasor measurement unit also, because artificial intelligence technique used to solve the state estimation, even though we got some minimized error in the 1% or 1.5% error when you are introducing the artificial intelligence techniques. But even though we have to rectify that error also, then we are incorporating phasor measurement unit in the bus system. So in IEEE 14 bus system, we placed three phasor measurement unit, and in IEEE 30 bus system, we used seven phasor measurement unit. So what is the purpose of phasor measurement unit thing? But the phasor measurement unit, it observe all the buses. If you place in the one buses, it observe all the buses. So in the accuracy also we will get more. So we can avoid the error by using the phasor measurement unit. But finally, to minimize the error in state estimation, we can use the artificial intelligence techniques, but we cannot eliminate completely. Then we can complete the error. State estimation error will be the neutral, will be zero, by using the phasor measurement unit. So thank you.